In this course, we're going to introduce you to some tools and to the browser itself, which is the environment where JavaScript runs. If you've got some understanding of HTML and CSS, that's going to be helpful. For example, here's a page. This is actually part of the assignment page for the Unit 2 project, and if I can get this thing to view page source, we can see the basic HTML that underlies this page. The HTML we do in this course isn't going to get a lot more complicated than this. Classes and IDs, and by weeks 8 or 9, some basic forms, HTML forms that you'll need to be able to create. With CSS, it's changing the size, color, and the visibility of different elements is about as far as we're going to get. So the more comfortable you are with that, the easier it'll be. But even if you're starting with very little HTML and CSS experience, it's not going to go crazy deep into HTML and CSS. Probably the thing that trips people up the most coming into an introductory programming course, and this course is no exception, is algorithmic thinking. The ability to sort of break a problem down into a methodical approach to how you're going to solve it using code. And that can be tricky because, before you understand a lot about programming and knowing what's possible, it's hard to know what's possible and how to solve the problem. So we're going to do a fair amount of that within the course of, presenting a problem that requires some sort of algorithmic or programmatic thinking in order to solve it. Let me give you an example of what I'm talking about. Project Euler is a great website that's got these sort of logical puzzles that often can be solved very easily with code. And I'm going to click on Archives here, and we're going to go and look at the very first one. It's called Multiples of 3 and 5. And here's the problem that they lay out. If we list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, and 9, and the sum of these is 23. Find the sum of all multiples of 3 or 5 below 1,000. So what I would recommend, and now somebody who's done a lot of programming, this will be sort of natural and instinctive, the way to approach doing this. If you haven't done a lot of programming and this is sort of like, whoa, what do I do with that? Perfect. Then this video is for you. Take a minute, hit the pause button if you need to on the video, and just think about how you would solve that problem if you had to solve that problem. You can even do it on a sheet of paper. I'm not saying solve the problem up to 1,000, but kind of work out the logic of how you would do that. And then you can start the video again, and we'll take a look at what the solution looks like. All right, did you really pause the video, or are you just letting it play? That's fine. You're grown up. You can do it any way you want. In any case, if we were to solve this problem with code, write some sort of pseudo code, not real code, but looks like code in order to solve it, it might look like this. For each number from 0 to 100, like basically count from 0 to 100, check and see if the number is divisible by 3 or divisible by 5, and if it is, add it to the total. So we could just count from 0 to 100 and check every number as we go. There'd be 100 steps to get there, and when we're done, we would have that total and be able to report it. Code is really good at doing stuff like this. Code is good at looping and doing things fast many, many times, even if that's kind of a brute force approach. Now, you could think of another way to do this, and if you did think of a way, maybe this isn't the way that you thought of. If you want, take a minute, pause the video, think about another way to do this that would have a similar sort of aesthetic to it, but not exactly counting from 0 to 100. And then we'll look at that solution. Okay, so the solution this time would be count by threes from 3 to 1,000, to 100. And then then we know each number is divisible by 3. I can actually take this off, can't I? Look at that. You can refine these things every time you look at them. I don't know how that got like that. For every third number, just count by threes and add them all up, and then go back and count by fives. And in that case, I just have to check and see if not divisible by 3, because some of them, like 15, is divisible by both 5 and 3. You don't want to count it twice. Count by fives, and if it's not divisible by 3, add it to the total, and then report the total. So this would be another way to do it. And then, in fact, if you did it this way, it might be a little faster, because this solution has us counting and checking 100 numbers. This solution, if I count from 3 to 100 by threes, I'm going to have 33 numbers that I counted. I didn't have to check any of them. And then every fifth number from 5 to 100, that's going to be 20 numbers, right? So I will have checked 53 times I'd have counted instead of having to count all 100 numbers. So this is an example of breaking a problem down into what can you do with code that's going to solve it. You can find a lot of these, and actually Project Euler is a good place. You can actually sign up for this, and once you've submitted an answer to or a potential answer to a question, you can go view everybody else's solutions to these problems. Some of them are very complicated, but many of them are sort of very simple logic problems. This is going to be where some people have the biggest challenge with the course. And so if you find this, what we just did, something that's totally new to you, I would say just be prepared for that. Be prepared for the fact that thinking this way about approaching the problems is going to be somewhat of a conceptual leap, and we will help you get through it. And we will work with you as the course goes on to introduce these concepts sort of, slowly. By the end of the course, you'll be thinking this way naturally, and it'll come a lot more easily to you than it may have right now.